কারণ সেই অগাস্ট মাসে আজকে আমরা এই অনুষ্ঠানটা করছি। আমরা বঙ্গবন্ধু শেখ মুজিবুর রহমানের বিদেহী আত্মার শান্তি কামনা করি। তার পরিবারে যারা শহীদ হয়েছিলেন সেই রাত্রে তাদের সবার আত্মার মাগফিরাত কামনা করি এবং তাদেরকে স্মরণ করছি। আজকে আমরা অনুষ্ঠানটা সাজিয়েছি, প্রথমে আমাদের একটি অনলাইনে একটা প্রেজেন্টেশন হবে। ডক্টর সুফিয়ান খন্দকার, উনি পানি বিশেষজ্ঞ, সিনিয়র ভাইস প্রেসিডেন্ট এবং ন্যাশনাল টেকনোলজি ডাইরেক্টর আরকাডিস, সেই সংস্থাটিতে আছেন। উনি আমেরিকায় বসবাস করেন। উনি আজকে আমাদের একটা আধা ঘন্টার প্রেজেন্টেশন দিবেন। এরপরে এই পদ্মা ব্রিজের আপনার ব্রিজ ইঞ্জিনিয়ারিংয়ের সাথে যুক্ত প্যানেল অফ এক্সপার্টের আরেকজন মেম্বার ডক্টর মোহাম্মদ আওয়াল, উনি সান ফ্রান্সিসকোতে থাকেন। এর পর উনি তার একজন ডিসকাশন হিসাবে একটা বক্তব্য রাখবেন মিনিট 10-এর। এরপরে এখানে যারা উপস্থিত আছেন তাদেরকে আমি একে একে মঞ্চে ডেকে নিব এবং আমরা তাদের বক্তব্য শুনব। আমি প্রথমেই শুরুতে ডক্টর সুফিয়ান খন্দকারকে তার প্রেজেন্টেশনটা উপস্থাপন করার জন্য অনুরোধ করছি। ধন্যবাদ।
ধন্যবাদ ডক্টর তামিম। আমি আমার বক্তব্যটা ইংরেজিতে করলে একটু সুবিধা হয়, তাই ইংরেজিতে করব। সবার কাছ থেকে মাপ চেয়ে নিচ্ছি, বাংলাও করতে পারে কিন্তু সময় বেশি লাগবে। Just to introduce myself, I graduated from Kuwait in 1967. I completed my postgraduate diploma in hydraulic engineering, specializing in river engineering, from Delft University of Technology, the Netherlands, in 1973, and completed my doctoral degree in geotechnical engineering from New York Polytechnic University. Professionally, আমি 1973 থেকে আমেরিকাতে আছি এবং এখানে কাজ করছি। ডক্টর তামিম জন বলেছেন ওয়াটার রিসোর্সের উপরই আমার মেইন কাজ, এবং আমি অনেক সংস্থার সাথে জড়িত ছিলাম, টেকনিক্যাল এখনো আছি। Currently, I'm serving as the advisor to the Bangladesh Atomic Energy Commission for the design of the first nuclear power plant in Bangladesh. Next. What are the major challenges faced by the Padma Bridge? First and foremost, of course, the Padma River. Tremendous flow, over 150,000 cubic meters per second. The bridge itself is a two-level truss-type bridge with pile foundation. That's something unusual. This pile foundation, we'll talk about that quite a bit. Another major challenge was the pier scour of the pier, seismic design, and of course the river turning wall. It was also designed for an impact of 4,000-ton ship or barge. Next. To start with the river. The Padma River at the site of the Padma River, as all of you know, is the third largest river in the world after Amazon and the Nile River in terms of flow. But Padma is the largest in terms of sediment transport in the world. Padma River is defined as a braided river. Next, please. What is a braided river? Next. Next, please. We river engineers grossly divide all the rivers in the world into three categories. On the left-hand side, it is shown as a straight river. These are very rare, only in the mountain region. During the inception of the river, these are narrow and kind of straight. Then when it enters the floodplain, then of course it has wide width. It can winding around, which we call the meandering river. Most of the rivers in the world are meandering river. The third category of the river is the braided river. that. Next, please. The meandering river, as you can see, follows certain laws of nature. It has a well-defined bend, and it follows certain criteria. It has a amplitude as well as wavelength kind of things. We also know in a meandering river, the outer bend, the outside of the bend, always there is scour, or inside of the bend is always deposition. And also the bend moves downstream at a certain rate. Knowing all those criteria that every meandering river follows, that it is much easier for a river engineer to design a river training work or bank protection work. These are predictable. Next, please. The third category of the river. Next. The third category of the river is shown on the right-hand side. These are the braided river. It has no definite channel. The channel shifts from one bank to the other bank in short time. And in addition to that, the braided rivers carry tremendous volume of sediment. The sandbars can develop anywhere. substantial. Now the load carrying is done by this pile in two mechanisms. One is the skin friction between the soil and the pile, and the end bearing. So normally most of the structures in the long piles are designed so that the end bearing is in a bedrock, but Bangladesh is the largest delta in the world. We don't find bedrock in a reasonable distance. Same is here. So the goal here would be that not to terminate the piles in the soft clay layer. It should be above that layer. Rule of thumb is 3 diameter of the pile, which is 9 meter, above the soft layer of stiff clay. This is the Bussinesque stress distribution for a load, typically. So that was the original design criteria for the pier foundation. Each pier has 6 piles, battered piles. Next, please. This is the drawing developed by the contractor, the 6 battered piles with a pile cap. The reason the piles are battered because it can take the lateral load generated from seismic event, and that is very beneficial. That's why all the piles are battered 1 to 6, I think. Next, please. The piles are tubular steel structures, very large diameter. The top part, 15 meters, was reinforced concrete. The majority of the length infilling was compacted sand. At the lower end was the trimmy concrete and a plug so that soil cannot enter the tubular structure. So that is the infilling for the piles. Next, please. Now these are the pictures of the piles, as you can see. This is on the left-hand side, as you can see, compared with the human being, how big is this pile size? These are 3 meters, almost 10 feet. Very large. It has never been used in the world. Such a large pile, as well as the thickness was 70 millimeter, accounting for the corrosion for 100 years. This concept of tubular steel piles was first introduced in Bangladesh for the Jamuna Bridge by a great engineer. His name is Ben Gardwick Jr. He's one of the greatest engineers from United States. I was fortunate to work with him. He was a consultant for one of my most difficult projects, which was the submerged intake structure for the St. Lucie nuclear power plant. As you can see, when they investigated all the piers, the soil, of course, varies quite a bit. And on 22 piers, it was found that soil may not have the adequate capacity to carry the load coming from the piers, roughly about 10,000 tons. So our engineers and the experts went to the drawing board and see how it can be resolved. Most of those piers are towards the Mawa side. The soils were not as great as was in the other side. So the solutions was very difficult. The consultant, several consultants, Cowie, COWI, plus another English firm. I had interaction with Cowie also. Finally, the design came up to be that one additional pile was added, the 7th pile at the center that was vertical. It can take the vertical load, no lateral. That improved the capacity of the pile system. And that I heard from my good friend, Dr. Shafiullah. I think he was the technical expert back in 2019. I last saw him. As you know, he passed away. As a matter of fact, when we started our career, Dr. Ainul Nishat, Dr. Shafiullah, and Shaukat and I all started our life in the water development design section. So I had pretty good interaction with them. Next, please. So the remaining pile structure, innovative design was done, was to improve the surrounding soil by skin grouting. The concept of the skin grouting is shown here, that these are the two section piles, and on those they have a double thickness socket. The grout is pumped into the piles, and through the perforation it will come out into the soil, enter the pore of the soil, and increase the strength of the soil and subsequently the skin friction. But in PADMA bridge, the piles were already fabricated. Those are, as I said, 3-meter tubes or steel pipes. So that was a little difficult to implement this standard concept. So idea was that this is what our respected GRC sir told, that channels are welded to the piles outside. All the channels had perforation. Then the grout was pumped into those annular space that will come out through those pores and through those openings and fill up the pores of the sand and subsequently increase the friction. But in PADMA, the problem was that the sand was very fine. And obviously the pores are so small, conventional grout will not be able to enter those pore space. So a special fine concrete was imported from Australia, and that was used for pumping grout and introducing into the soil and increase the capacity. And that worked. Two load tests were done, and it showed substantial improvement in the skin friction. Next, please. The driving of this kind of pile is also unheard of. This 3-meter diameter pile going a length between 98 meter to 122 meter is unbelievable. The two hammers used in the Jamuna bridge, the length was a maximum 80 meters were also used. Then a specially designed hammer was fabricated in Germany by the Menk company that was used to drive the piles to the design depth. It was unheard of. This is never done in anywhere in the world. Next, please. Another problem was the scour. Scour evaluation that was done by Northwest Hydraulics of Canada. I personally know them very well. I have used them for several model study for my projects. I knew their principal, Vic Galley, was a very close friend of mine. And I knew that we are in good hands. They are one of the best in North America. They did the model study and came up with computation as well as model study and came up with a potential scour of 62 meters, unheard of. I have been involved in the scour evaluation in America and one of the pioneers on the scour evaluation. I never have seen or heard this kind of scour in the world. Next, please. This is a conceptual idea of the scour at the PADMA bridge. As you can see, the top 15-meter, what we call general scour, and the remaining 47-meter is the local scour or the pier scours. So basically this pile cannot get any contribution of the first 62 meters because there is no skin friction there, it's just the water. So that was a tremendous design for the piles. Next, please. Again, as I said, I am involved in the scour evaluation in the United States, and I give lectures to the bridge engineers and highway engineers how to evaluate the scour at bridges. Next, please. Prior to 1980, there was no organized methodology, even you will be surprised in the United States, how to determine the scour. But in a short span of 3 months, 3 major bridges failed. Schoharie Creek, Hatchie River, and Ariel. The Schoharie Creek really created a tremendous political impact. It is in the New York. Due to the failure of that, 10 people were killed. So government take a crash program. Next, please. Federal Highway Administration was given the authority to come up with a program, and they contacted American Society of Civil Engineers. We formed a task committee to produce a document known as Hydraulic Engineering Circular HEC 18, evaluating scour at bridges. I was a member of that committee under the leadership of Professor E.V. Richardson. This is now considered as the Bible for evaluating all the bridges in North America. Next, please. This is the cover sheet of the document. Next, please. Again, over 500,000 bridges were evaluated by 2000, and 5% of those bridges are considered to be scour critical, needed some protection, which has been implemented. And we hope that in the future, there will be less failure of the bridges in America. Next. So how the scour takes place? In a flowing river like Padma, where the peak velocity could be as high as 4 to 4.5 meters. When you put an obstruction to the flow, then the flow gets separated and creates a vortex at the bottom. Because of the shape, we call it horseshoe vortex. That lifts up the soil from the bottom, and the ambient current carries those sand and creates a big hole around the pier. Next, please. This is a project in New York State called Castleton Bridge. It's the large bridge over Hudson River. As you can see on the left-hand side, there is a pier and shows those big scours. Next, please. As you can see, the scour could be pretty big, even in a relatively milder river. So Padma is a very difficult river, very high velocity. So the computed scour was total 62 meters. Next, please. Next. So this is conceptually we present the scour. The top part, the yellow one, we call it general scour or contraction scour. This will happen in every river, irrespective of any structure. Whether we build a structure or not, it will happen. But the red part is basically due to the obstruction or flow separation at abutment and piers. And that is a predominant scour at Padma, as you know, that was about 47 meters. Next, please. One of the things I did not see, and this is my question to the expert panels, is that I haven't seen anywhere that for the pier scour, any countermeasures was proposed or being considered right now. This is the standard practice. We designed countermeasures for the pier scour as it is shown on the left-hand side. Normally, in the United States, we use large riprap, sometimes some geotextile bags underneath the hole. But the criteria here is that the top of the countermeasure has to be flush with the bottom of the river, so it does not create any additional obstruction to the flow. On the right-hand side, I have seen an innovative design. This is called articulated concrete blocks. The individual small blocks are laced together with polythene ropes, and that way we can create a very large flexible mattress, and that can protect the scour when it initiated. This has been introduced for the first time in Bangladesh at the Rupur nuclear power plant, and the contractor for this innovative design was Max Group. My good friend, Engineer Alamgir, was involved. Next, please. Now, one of the things I heard from one of my good friends from Kuwait, that one of the concerns was the migration of Elish fish, that this pier scour may interfere with the migration of the Elish. Of course, Padma is world famous. Padma Zilish is the world famous. We cannot impede the migration of the fish. So let me try to share one project I looked into. I had the opportunity to visit. Next, please. I was in Wuhan, China.
Dr. Khandekar,
Yeah.
you have about 5 minutes to finish it if you can. Is that okay?
Okay, I'll try my best.
All right,
Okay.
thank you.
So in Wuhan, I had the opportunity to visit that largest hydroelectric power plant, and they have a specific problem of fish migration. Next, please. Next. Yeah, they had introduced fish ladders, fish elevators, but one of the most famous fish is the sturgeon. So that could not migrate. So they had to artificial create the hatchery and introduce this fish on the downstream side of the dam. So if there is a problem, we can address that. Next, please. I have to move fast. One of the major, as I explained, was the river work, turning works. As you can see on the left bank, 12.4, on the right bank, actually, towards the flow. Left bank 3 kilometers, and this was a major effort. And this is a very, very innovative design. Next, please. The river was excavated up to elevation minus 28 meters. That was the capacity of the dredges, and those are filled in 3 layers of geo bags. On top of the next, please. On top of the geo bags, they put the armor layer. Next, please. These are the concrete blocks. I think each weighs about 165 kg, were put on top of those bags in layers and act as a armoring. Next, please. Next. This is the finished product. It was done by Sinohydro, one of the largest project, over $1 billion cost. Then it is expensive, but again, nobody has handled Padma River. Next. The other one was the seismic design, as it is shown on the left-hand side. I think Dr. Awal is more familiar with this one. If we have a fixed bearing to transfer the load to the substructure from the superstructure, then there is a potential of failure of the superstructure. So isolators or bearings are used to separate that so that the lower part, the substructure, can move independently of the superstructure. Next, please. Friction pendulum bearings were used. These are monsters, very big. Never ever fabricated such a big bearings in the world. It was done in Wuhan, fabricated. Next. These were, next please. These are very big structures. As you can see, this is the actual picture. I think it weighs about 15 tons each, largest one, and it can carry a load of, or transfer the load of about 10,000 tons. Next. The last thing was that the piers are designed for the impact from a 4,000 ton vessel, be a barge or ship. This is shown a ferry hit the pier number 17. Of course, nothing happened to the pier. A lot of people are injured in the ferry. So this has been extensively designed, this bridge, and it has solved so many challenges. Next, please. This is one of the projects was done in the Netherlands called ZZ project. This is considered as one of the wonders of the 20th century. And next, please. ASC, American Society of Civil Engineers, they identify major projects as the engineering achievements of the 20th century, and ZZ is one of them. Next, please. I think Padma Bridge qualifies to be recognized as engineering marvel of this century, 21st century. Why? The bridge is over the most difficult river in the world. Double-decker bridge with truss system is a unique and rare design. The pile foundation is France